Hi, my name is Aaron Levy, and I'm a software engineer at CoreOS. I wanted to make a recording of a presentation that I gave at a Kubernetes meetup recently that went over self-hosted Kubernetes and then also a tool called BootKube that we've been developing here, which helps you to launch self-hosted Kubernetes clusters. So when I say self-hosted Kubernetes, what exactly do I mean? In short, this could be described as Kubernetes running on Kubernetes. And what that means is that Kubernetes is responsible for managing its own core components. So things like the API server, the controller manager, the scheduler. And those components are actually defined as higher level Kubernetes API objects. So they would be defined as things like a daemon set or a deployment. And being those objects, Kubernetes is managing them internally, just like any other piece of software that it would be managing. And what that means is that the on-host requirements end up essentially being that you have a kubelet and a container runtime. And then everything else is layered on top of that, including the core Kubernetes components themselves. So why do this? Why self-host a Kubernetes cluster? Well, one of the main reasons is, we already believe in kind of containerizing our applications and deploying them in that manner. If we're already using Kubernetes, then our applications are being deployed as containers in pods. They're being defined as declarative configuration in pod specs or higher level objects. So we already believe in kind of that model, and so why not use that same model for the core Kubernetes components themselves? And then once we've done that, Kubernetes is also great at managing the lifecycle of our software. So we deploy our software into these Kubernetes clusters, and then using the mechanics of Kubernetes itself, install, update, manage these pieces of software. So why not use Kubernetes to manage itself as a piece of software? So kind of specifically, like, what are some things that we could get out of a self-hosted cluster? And a big one of those is API-driven updates. So what that kind of looks like is we're able to modify the state of our cluster via the Kubernetes API. And so in this case, it could be something like I wanted to change something about my scheduler, update my scheduler. I could modify a manifest for the deployment of the scheduler, and then I can use the typical Kubernetes tools like kubectl apply to apply that change to the cluster. And what's happening behind the scenes is that the deployment controller is actually doing a rolling update of that component. So it's launching new pods and then destroying old pods so that now your desired state, that your actual state matches the desired state that you've just applied. And this is just something that is built into Kubernetes itself. So as a user, I'm just applying my configuration change, but internally what's occurring is this rolling update of a piece of software, and in this case, a core piece of software to the Kubernetes cluster itself. Another thing that we get is cluster introspection using the typical Kubernetes tools. So you could use something like kubectl logs to inspect pods and the logs of pods on your system, and that can include core components of Kubernetes. And so you get the same kind of entry point into debugging and introspection of your cluster for all of the typical components, rather than having to kind of have two separate processes, one for your software and another for these core components. Or maybe something like secret rotation. Like, let's say that we wanted to update some TLS assets for the API server. What we could do is we could put those new assets inside of a secret, and then we create those, kubectl create, and inject them into the API. And then we update our API server manifest to use those new secrets. And so now, anytime an API server pod is scheduled to a node, it's also going to retrieve those secrets, and in this case, the newer set of secrets that we wish to have. So another really big reason that self-hosting can help us out is upgrading Kubernetes right now can oftentimes be a difficult process. Part of that is because if we say are deploying these components maybe as just static binaries on the host, or even as static pods on various hosts, it's our responsibility to go reach out to each of these nodes and essentially update files on disk. Maybe it's changing image version flags, or maybe it's just changing flags on the binary itself. But that means that now the responsibility of updating the Kubernetes components is using an external tool. So it's using something like configuration management, or maybe you're SSHing into your boxes and updating the pod manifest. In a self-hosted cluster, we essentially are going to just be interacting with the API itself. And so, a manual update of Kubernetes would look something like kubectl apply updated manifests of all of our core components. So it could be API server, scheduler, controller manager, proxy, and kubelet. And then letting Kubernetes manage rolling these pods across the cluster, updating wherever they may exist in the cluster, rather than us saying, okay, I need to make sure to reach out to every node that may be running an API server or maybe running a scheduler and update these files on disk. We let Kubernetes and the mechanics that are built into it handle that for us. Now, when I describe an update this way, we're not quite there yet to just be able to run these 5 apply commands and have an updated cluster, but we're not that far away from it. So I actually want to demo upgrading a self-hosted cluster. So I already have a 2-node self-hosted cluster here. I used bootkube to launch this, and I'll go into a little bit about what bootkube is and how it works in a little bit. But just so we can get started quickly, it's already been launched. So we can see we have the 2 nodes as part of the cluster here. And then if we look at what a self-hosted cluster actually looks like, let's take a look at the daemon sets. Okay, so we have 3 daemon sets in this case, one for an API server, one for a proxy, and one for a kubelet. The API server itself is a little bit special in this case because we've given it a node selector that says we only want the API server pods to end up running on nodes that have the label of master as true. So in this case, we can see it's only ended up on one node. And then in the case of the kubelet and the kube proxy, those are also both daemon sets with no node selector because we want to be running both the kubelet and the kube proxy pods on all nodes in the cluster. And then if we take a look at the deployments, you can see the other core components, which are the controller manager, the scheduler, and in this case the DNS add-on. And so we have 1 copy of those each running in the cluster itself. So what we want to do when we update a cluster is we first want to update the control plane, and then after that we want to update the kubelet and the kube proxy. So what we're going to do first is we're going to update the API server. Now, before we do actually, let's take a look at the version of the cluster. So my kubectl binary locally is actually a bit old of a version, but the API server itself is running a 1.3.0 API server, and then the metadata at the end of this is CoreOS build specific, but in this case it's a 1.3.0 Kubernetes cluster. So we want to update the API server, so we need to modify that daemon set. Now, before, when I was saying that there's a couple things that we still need to do, we're not quite to that point of really simple cluster updates. One of those things is that daemon sets don't support rolling updates yet as part of core Kubernetes. And so in this case, we're going to need to roll the update across the cluster. But so the first step of that is to, should be extra. The first step of that is modifying the manifest for the daemon set itself. And so in this case, I want to bump this cluster up to 1.3.2. And again, this is CoreOS build metadata. But So we're going to go from a 1.3.0 API server to 1.3.2 API server. Now that's been edited, but because we don't have rolling updates, there's nothing that's actually applying that update to existing pods. If new API servers were launched right now, they would get the new version, but the existing one, we're going to have to roll it ourselves. So if we take a look at the pods in the cluster, we can see that the API server, the name, kind of an oddly randomly generated name for this API server pod, PUTZZ. What we're going to do is we're going to manually delete it so that the daemon set controller will see, well, there's no API server pod running on a node which it should be running, so I'm going to start a new one. And when it starts a new one, it's going to use that updated manifest we just updated the version in. So let's go ahead and delete this pod. All right, now that I've deleted it, the API server is not going to work anymore because we just deleted, the thing that's running it. So we need to wait a second for that to come back up. So in the meantime, I can go over a little bit about bootkube itself. So if you want to look into bootkube, take a look at the GitHub page for it under CoreOS/bootkube. Documentation there, pre-built releases and such, reference implementations. So if you want to launch some local clusters and kick the tires, some good details there. But then we also wrote out a document kind of talking about self-hosting and the kind of design details behind it for all of the components, and where we kind of see this moving forward, some of the pieces that still have work to do. And so that you can get to via this link. But take a look at that. It goes much more in depth than I'm going to be able to talk about here about how bootkube actually works. But to just talk about it in a general sense, bootkube essentially is a temporary control plane, which runs on a single node, the initial node that you need to bootstrap, long enough to be replaced by an actual self-hosted control plane. So when I say a temporary control plane, that means it's a single binary that runs an API server, a controller manager, and a scheduler. And it runs long enough so that you can inject these assets, like the deployments and the daemon sets, into a temporary API server, and then those pods will be started, and then it will see that a new control plane, a self-hosted control plane, is taken over, and bootkube will just die, and then you don't need it anymore. Past that point for your cluster lifecycle, you're just using Kubernetes, native Kubernetes tools to manage the actual lifecycle, the cluster itself. Now, the reason that this temporary control plane is necessary is that we're kind of on the very first node to be launched, we're in a chicken and egg situation where we want to be able to create these higher level objects like deployments and daemon sets, but we don't have an API to actually create them against. And so we need to have a temporary API there for the interim, just long enough so that we can inject these objects and then pods can start being scheduled. Let's go back and see if our cluster is back up. Okay, so we got a new API server pod that was launched. So you can see by the suffix there that a new pod has been launched there, and also in terms of the age itself, 1 minute old compared to the rest of the cluster. So now if we run the version command, we should see that the API server has been updated. So we have a 1.3.2 API server now. So the next step is actually updating the controller manager and the scheduler. Now these are deployments rather than daemon sets, and deployments natively support rolling updates. So what we're going to do in this case is if we edit one of those, I'm going to do the controller manager first, and I'm going to do the same thing and just tick this image up. Now, I'm going to wait to save this for a second and explain what's going to happen, because we might actually miss it depending on how fast it is. So when I save this, the deployment controller is going to see that my manifest has been modified and it no longer matches what is actually deployed into the cluster. And so it's going to start a rolling update of existing pods that were managed by this deployment to match this new configuration. So I create it, and then we can just do get deployments. So we can see now that we have a desired copy of one controller manager, but because we've just modified it, we don't have any that are current or up to date or available. And what we're going to see is that, well, it was too fast, but now a new pod has been launched. What we might have seen is, the status saying container creating, because we just rolled that that pod itself, and you can see here that the controller manager is 28 seconds old. So we've updated the controller manager. Now let's update the scheduler. All right, we can try and get pods and see if we can catch that one. No, it's already been updated. So the scheduler 2 seconds old, because the image was already local to that machine, because we've updated these other components. So it was already downloaded by then. All right, so now essentially our control plane has been updated. We updated the API server, we updated the controller manager, we updated the scheduler. Let's update the kubelets and the kube proxy. So one of the things about, to just show the version change on the node side, is we can get more information about the nodes, and we'll output it in YAML. So one of the things we can see here is under node info, and this is just one of the nodes, I could scroll up and see the other, but that these are both running 1.3.0 for the proxy version and for the kubelet version. And this is part of the node object. The kubelet is always updating the status of the node object itself. So let's update these. And this, again, both the kubelet and the kube proxy are daemon sets. So again, we'll have to update the daemon set, but then we need to kick each of the pods so that they get recreated. Let's do kube proxy first. All right. And okay, so nothing would have changed yet. But we can, now that once we delete each of these pods, oops. All right, and that switched over pretty quickly. So that's 2 seconds old. So let's update the other proxy. That one's done. All right, now let's update the kubelet. And then do the same. We'll kick each of those pods individually. And this can take a little bit longer to do. All right, so we see that one's now pending. And we've got a running kubelet. And let's do the last one. All right, so now we have a fully updated cluster. So we did the entire control plane, and then we did each of our nodes by updating the kube proxies and the kubelet. If we were to inspect the nodes themselves now, the node objects, we can see that the node object is reporting that the kube proxy and the kubelet version have both been updated as well. So we were able to do this without having to SSH into host or change files statically on the host. We do this all just via kube control commands over the Kubernetes API. Let's say that we wanted to scale the schedulers. Forget the actual replicas, that's it. And then get the list of pods. We can see now we have 2 schedulers running in the cluster just by updating that just by using kube control. And if we were to inspect the deployments, we see that our desired matches the actual. So anyway, it's interacting with our Kubernetes cluster and modifying the core components of it in the same way that we would do this for our applications. And it gives us all of the really nice tooling of Kubernetes to do something like just upgrade your cluster really easily. And in this case, I was doing this a very, very manual way where I'm live editing the manifest using the edit command. And then in the cases where something like rolling updates aren't implemented, I'm going through and I'm kicking the pods. But that's something that very likely isn't too far away to be supported upstream in Kubernetes, or something that isn't insurmountable of writing a piece of software logic that is responsible for updating your cluster for you and doing those things like, well, I'm going to update the API server first, and then I'm going to roll the pods, and then I'm going to update each of these other components. And so, ultimately you could get to a place where the actual whole deployment or the whole upgrade process is automated, but even just the by hand manual process right now is actually pretty far along. So anyway, thanks for watching, and I hope you enjoyed the self-hosted cluster demo, and please reach out on the Kubernetes Slack or via GitHub if you have any questions. Thanks a lot.